Good morning. So today we are going over composite figures. All a composite figure is just a couple of different shapes that we've already learned, like triangles, parallelograms, trapezoids, rectangles, or circles, also squares. And they're kind of added together. So the formal definition is a composite figure is a figure that can be separated into regions. In order to find the area of that, you're going to divide each region into its shape, find each area, and then add them or find the sum. So in order to do this, it is easiest if you use different color highlighters. So here are my highlighters. And I'm going to just highlight each shape a different color. So I've got a square here. That'll be green. And I've got a triangle here. That'll be purple. And then I've got this trapezoid down here at the bottom. That one I will make yellow. So I've got all three figures. And I am just going to find the area of all three of these figures. So I'm going to start with the square. It's the easiest. Actually, yeah, I'm going to start with the square. No, I'm going to start with the triangle. Let's go triangle. Triangle is going to end up being the easiest just because we've got two of the pieces. In the square, we don't know what the sides are yet. I'm going to zoom in so you can see a little bit better. Okay, so if I were to redraw this triangle here that I just outlined, it would look like this. I just flipped it to make it fit better. It tells me the height of my triangle is 9.6, and it tells me the hypotenuse of my triangle is 12. I'm missing the base. Well, this is going to be half of my base. Now, in order to find a missing side in a right triangle, we're going to do the Pythagorean theorem. Because I'm missing a leg, I'm going to take the hypotenuse, square it, and subtract the other leg. If I were to type all of that in my calculator, I would get 7.2. Then, if I multiply it by 2, I would get 14.4. I was a step ahead of myself. So that means this whole base of this triangle is 14.4. Now, I can find the area of this triangle because I've got the base and I've got the height. Area of my triangle is 1/2 base times height. So I'm going to say 0.5 times 14.4 times 9.6. That gives me an area for that triangle of 69.1 meters squared. Now, square is the next easiest because I've got one side now. So now that I've got that one side, I know a square is just side squared. That side was 14.4. So I'm just going to say 14.4 squared. Same thing as saying 14.4 times 2. So now to say 14.4 times 2, or 14.4 times 14.4, that would give me 207.4 meters squared. Now I've got one more to do, and that would be this trapezoid down here on the bottom. I know in a square all four sides are the same, so I know both of the bases of my trapezoid. Base 1 is the 10, base 2 is 14.4. I've got to figure out the height. Now it tells me both the square plus the trapezoid are 25.4. If the square was 14.4, in order to find the height of the trapezoid, I'm just going to take 25.4, subtract 14.4, and that would give me the height to be 11 meters. Now I've got the bases and the heights, so I'm going to come back over here and just plug all of those numbers into my formula. I've got my area is equal to 0.5 times the height times both of the bases added together, yes. If I type all of that in my calculator, I would get the area is 134.2 meters squared. So I've divided up my composite figure into 3 different shapes. I found the area of each different shape. Sorry about that, there was an announcement. And now I just have to find the sum. So I'm going to add all 3 of these numbers together. 69.1 plus 207.4 plus 134.2. When I do that, that should give me an area, composite area, of 410 meters squared. Remember, area always had squared units. See if you can get one step ahead and divide these shapes amongst what they are. Okay, so hopefully you've had enough time to figure out which is which. I've got 2 semicircles here, but because they're both semicircles, a semicircle plus a semicircle just equals a circle. So I'm going to do both of them in the same color. So those are both going to be yellow for me. And then in the middle here, because I have 2 bases that are the same, that's going to be a parallelogram. And I'm going to start with the semicircles. Now, if you remember when we were doing our notes over semicircles, our notes over circles, there was a semicircle and we changed our formula slightly. It was area is equal to 1/2 pi r squared. Because this is 2 semicircles, or just a full circle, I'm going to use the regular formula and not worry about the halves. I would just have to add them together, and that seems like a wasted step. So here, if I look at this semicircle, it tells me that the radius is 6. So all I'm going to do is take pi 6 squared, or pi radius squared, and I'm going to put that in my calculator, and that would give me 113.1 inches squared. This one's very straightforward, very easy. If you look at the parallelogram now, I know a parallelogram is just area is equal to base times height. I have my height here. It might be kind of hard to see in the video. It is a 5 right there. So I know my height is 5, and I know this is my base. Now, the base of this parallelogram is going to be the same as the diameter of the circle, not the radius, because I don't want half of it. I want the whole thing. So that means it's 6 inches plus 6 inches, which gives me 12 inches. So that means my height, or not my height, sorry, my base is 12. In order to figure out what the area is, I'm just going to multiply those 2 together. That would give you 60 inches squared. Now I've got to add these together because composite figures, you find the area and you add them together. So I've got 113.1 plus 60, which gives me 173.1 inches squared. Oh no. There we go. 171.1 inches squared. Now you can also do this the other way. The other way is if you are looking for part of something inside of another figure. We call those shaded regions. Now in this shaded region, you find the area of the shaded first, then you subtract the non-shaded. Where I set my pin down and I already lost it. Entire, and then subtract. So if you look at this, my entire figure, the shaded one, that is the square. If we remember, the area of a square is just side squared. So I'm going to say this is the side, right? That's the edge of my circle. So that is S. So in order to find the area, it is just 25 squared. If I type that in my calculator, I get 625, don't forget your units, feet squared. Now I've got to figure out the unshaded region. The unshaded region is a circle. So I'm going to write down the formula for a circle. Area equals pi r squared. Now I have to figure out what the radius is. I know that this whole side is 25. So that means this whole line here would also be 25. This is the same as this side. That means the diameter of my circle has to be 25. Now, if 25 is equal to my diameter, how do I find radius from that? I divide it in half. So divided by 2 gives me the radius. 25 divided by 2 should give you 12.5. So now I can just plug it into my formula. Area is equal to pi times 12.5 squared. If I type that in my calculator, I'm left with an area of 490.9 feet squared. Now I found the entire figure, and I found the non-shaded region. Now I've got to subtract. I am seeing what is left when I take away that unshaded or the non-shaded figure. So I'm going to say 625 because that's the bigger one. That was my shaded region, minus 490.9. That's the unshaded. When I put that in the calculator, I'm left with 141.1 feet squared. Ah, you get the idea. Okay, now if I go to the next part of my notes, there's only one more problem. What is my shaded region here? My shaded why are you zooming out? Here we go. My shaded region is my rectangle. So for my shaded region, I know that that formula for area is length times width. To find the area, I'm going to multiply both sides of my rectangle. That would be 25 times 14.
Our center will leave in about 3 minutes. If you have duty in the morning, please get to your spots. Thank you. Have a great day.
So sorry that you heard that. Tried to pause it, and I just think we got all the announcements out of the way. So I'm going to multiply these two numbers together. When I multiply 25 and 14, I get 350 centimeters squared. Now next I have the unshaded. My unshaded here is a triangle. And I know the base of the triangle already, because if this is one side of the length of my rectangle, it is also that same length on the other side. So my formula for my triangle is half base times height. Let's see if I can make it all fit. There we go. So I'm just going to plug in what I know. It tells me the height is 11. We just established that my base is 25, and 0.5 is easier to use than 1/2. I'm going to type all of those things in my calculator, and I am left with 137.5 centimeters squared. Now, same as in the one before this, because I am trying to find what is left when I take away that triangle, I am subtracting. So that becomes 350 minus 137.5. When I type that in my calculator, I am left with 212.5 centimeters squared. If there is nothing shaded, remember, you are going to add. If there is something shaded, you are going to subtract. Hope this helps.